All right, you guys ready for the post-lunch session? Yeah. Okay, so Melissa Valentine is going to be talking about her work called Becoming Informated, How Expert Occupations Gain Reskilling During Algorithm Development and Use. And Melissa's coming here from Stanford, so take it away.
Yeah, thank you so much. All right, hi everyone. So I'm from a department at Stanford called Management Science, and several of our alumni you've actually heard from. So Paul, Liz, Hatem, anyways, we have a great program, and it's like so exciting that all of us get to be here as part of this. Anytime Nosh invites you to do something, I actually specifically listening. So really grateful to be here. Thanks to Dr. Chow for funding my research, NSF Career Grant from
I recognize that name.
Yeah. Okay, so the title of my talk is Becoming Informated, and that is a reference to Zuboff's book on the age of the smart machine, Becoming Informated, and this is referring to kind of the tension that is seen with algorithms where there's a possibility of people becoming replaced, automated, de-skilled, but then there's also a chance that people could become augmented. I think the 2023 word that we're using is augmented. In the 80s, Zuboff said informated. So that's what I'm talking about. I'm going to present to you a success case. I got very lucky. I got access to a great tech company, great data scientists, and it ended up being this really successful case where by the end of it, the knowledge workers were in fact informated. They were augmented. So it's actually like a positive tech story, which I'm excited to be able to share with you how it came to be that some of the experts became informated. So how did that happen? So the literature that I'm talking to start with is about why we would expect resistance to algorithms. Most studies and most talks you will find that experts are going to resist attempts to formalize their work, resist attempts to control or quantify their work. That's because people care about what they do. It's it's like rewarding to develop expertise, to develop knowledge, to contribute to your organization. Organizations and managers then will recognize the value of that expertise, and then they want to learn from it. So this is clear back to Frederick Taylor. He's let's count exactly how people shovel. Let's learn from that. Let's standardize, and let's make everyone do it the best way. And that's not the worst idea, right? We do want efficiency, we do want productivity. But it ends up setting up this kind of contested control between experts and their employing organizations. The experts figure out cool ways to do things, they're attached to it, the organization learns from it, they extract the knowledge, they formalize and they standardize, and then they start to impose it on people. This is the way you should be doing things. So people are nodding along. I think this is a familiar story. This is why we expect resistance to formalization. And with formalization, that can happen with any kind of artifact, right? That can happen on paper. And in the 80s and the 90s, you would see, standard workflows. That's formalization. We're now seeing formalization happening in algorithms. Hudson did a great job of talking about the affordances of algorithms. Now they're instantaneous, they're interactive, it's comprehensive data. So formalization has become much more powerful, and there's potential for it to become much more controlled. So we might see different dynamics around resistance with algorithms, but I think many of the studies that we see still are predicting you're going to see a lot of resistance from experts whenever you have a situation where their work is being surveyed, standardized, and controlled. So this is what the literature tells us to predict. At the same time, we also hear kind of the more aspirational vision that technology change can lead to augmented workers. It can lead to there's a literature on occupational change. We'll use the word reskilling. You might get reskilling, you might get upskilling, where this valuable technology comes in, the organization has extracted all this knowledge, and then they're making superpowered workers. That's also, there's an aspirational vision that happens. So this is a great book, and I'd like to thank reviewer 2 for telling me about this book. There's a great book that has looked at the history of technology change and occupational skill. And this book has done a really nice job of looking at the dynamics of it. And they say, oftentimes we talk about these things like they're separate, but this is often happening at the same time in the same organization. An algorithm is introduced, or whatever technology it is, High status occupations are likely to be reskilled or augmented. Some low status occupations will be automated, they will be standardized, they will be controlled. And what you're likely to see is new occupations, oftentimes outside of organizations that are low skill. So a lot of times, like the gig economy and like remote work right now is having some of that like low skill outside of organization occupations. So we sort of know this happens. So the earlier literature is saying let's expect resistance, but what we don't have is a connection between this idea of reskilling and the idea that you should expect experts to resist. And again, the idea of reskilling got picked up or sort of elaborated on in a great theory by Zuboff. So she looked, I mean, and this is in the 80s, but I don't know if you guys, I like read this again for my revision. This book is brilliant. It's so smart. Oh my gosh. So I've been reading it and it's like, it's applicable today to like all of the algorithms that are like happening today. So anyway, so she has this idea of workers becoming informated. And what she introduces that I'm going to draw on in my study is the idea of like, what does it mean to be informated? And she says what people are actually gaining is new conceptual thinking skills. It's new abstract thinking skills. And what's interesting is these skills are consistent with managerial skills. What I mean by that is like, think about like the Frederick Taylor stuff, like you study work and then you can think about it abstractly. So you're not the one who's shoveling, you're the one who's like variable, shovel, measurement, shovel rate, optimize, shovel rate. So that's like intellective thinking, that's conceptual thinking, that's how managers think. So the interesting thing that she was seeing is that a lot of at this time it was like manual laborers were learning how to think conceptually about their manual labor. So what I find in my study and what I'm going to show you is basically these kinds of intellective skills are like the reskilling or information that is happening is people like picking up these kinds of skills in new ways. So I'm going to show you what my prediction that you're going to answer this question, like when are you going to expect that high status expert occupations will embrace some sort of algorithmic transformation of their work versus resist it? So what I'm going to show you is an example where these experts were reskilled. They were given new high-value intellective skills similar to what a manager would have. So instead of a manager getting them and doing it to them, they themselves developed these new intellective skills. And I'm suggesting, I'm going to show you that under these conditions, I think we'll see knowledge workers embrace algorithmic technologies. Cool. All right, so methods. All right, so this was an ethnographic study. I spent 10 months as an unpaid program manager at a company I'm going to call AlgoCo, downtown San Francisco. I went there, I went up the skyscraper, I did work for them. That allowed me to get access to all of their communication data, interview data. I did virtual observation, qualitative, quantitative. It was a company that I was like, not every tech company is like a fun place to do ethnography, but it was great that people were very excited about what they were doing, and the data scientists that I studied were very empathetic to the users. So it ended up I just was very lucky. It was just like a great success case. The reason that I sampled this company is because they had a centralized algorithms department that had just a huge amount of data. It's digitally native. They founded it. They built the company around the first algorithm, basically. So anyone who got hired there was understood what they were getting into. And I love this phrase. They had a chief algorithms officer, and he said that they had infinite and elastic compute resources. I don't know if I know exactly what that means, but don't you want it? Right now, I had infinite and elastic compute. So I wanted to, so I was there just kind of generally understanding how they were structuring their data science teams. But I really wanted to understand how algorithms are changing work. So I designed a specific study within this 10-month ethnography to do a very specific pre-post on a new algorithm. The one that I ended up picking, and not because I am actually that, I picked it because I could get a very clean baseline, and I could be there for the development, and then I could have a post and see how people were actually working differently. So it turns out that the algorithm team that I studied, they were studying the process of planning inventory. So the profession that does this they're called fashion buyers. So the fashion buyers it's this whole occupation across the whole fashion industry, and their job is to know what's hot in fashion and then buy it into their company's inventory, and then the company sells it to their customers. It's high status. I didn't know anything about this before I got there. I was there for the data, but I learned so much about fashion. So they're very high status. Like the vendors are like selling to them. Like I followed them to New York, and like the vendors like give them gifts, and like they're so cool. They're so high status. And their job is to like pick out the clothes. They're not there for the data, but they are at a tech company, so they are doing a very kind of data-driven thing before. Okay, so I really want to be clear about the way that they did their work before and after. It took me a long time to try to think of an example that would make it really clear for how this worked. So I'm gonna try, so for right now, we're not social scientists. This is like, we're just trying to understand the way the algorithm works and the way that it changes their work. So before, what would happen is, so you have a fashion buyer, high status, they're there for the fashion, and then they have a planner who works with them. The planner's job is to compute all of the metrics that go with the buyer's plans. So the way that they would work is they would get a budget. So let's say that my job is to buy all the jeans for like the women customers. I would get a budget. I would get $10,000 to spend on 1,000 pairs of jeans that I'm going to send to the customers. So I have a budget. I have $10,000 to spend on 1,000 items of clothes. And then they start to give me some other things. So all of these are like targets before I make my decision. They're telling me, here's all the things that you're accountable for. Spend $10,000 on 1,000 jeans. So then I go to so the reason I have a cart, so this is a metaphor. So imagine the way that I do this is I go to the store. I'm like at the grocery store with my planner. So I'm pushing the cart and my planner has a calculator. And I'll like put a pair of jeans in, and then they'll put it in the calculator, and they'll be like, you just spent $1,000. And then I put another pair of jeans, and then they're like, oh, 100,050, or like whatever it is. So I keep putting things in, and then I check back with my planner. And then I put more stuff in, and then I check back with my planner. So the planner is doing all the computation based on what is in my cart. I'm being guided by the budget. So it's very iterative, and it's very back and forth. So it's data-driven, but it's very manual. Does that make sense? All of this is happening on like data platforms, so they feel very data-driven. They're like, I'm at a tech company and I'm data-driven, but that is how their workflow is. Okay. So let's say that they're at the store, they put all this stuff in their cart, and then their planner, literally with a calculator, that is true, then like fills it out and is like, oh, you put all that stuff in and you've only spent $8,000. You have $2,000 more. I'm back to the store and like putting more stuff in. Okay. So that's how it used to be. Now, what the data scientists are going to build for them is an optimization algorithm. So the way this is going to work now is they're going to put those numbers into the algorithmic interface. They're going to say, you know, I need 10,000 units of whatever, and I want to have 30% of them come from vendor A. I want 70% of them to be boot cut or whatever. So they put the targets in, and the algorithm will recommend an inventory that optimizes that. Fast, by the way, fast. It just does all the computation of all the metrics based on what you put in the cart. Fast. So now now the buyer, instead of putting things in the cart and like trying to like guess and check to like try to get to the optimization, everything's just calculated. They like up front say all this stuff, bam, here's the inventory, bam, here's your optimize. Cool, so fast. This is a screenshot of what it actually looked like. So, like so fast. So screaming fast. Okay, so I was saying, think of it like this. So instead of like, put the things in, check with your planner, blah, 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 in which case you basically only ever end up with one plan. When everything is like calculated automatically like that, it's like, basically what you have to do now is like look at like, because there's there's like infinite ways that you could make the inventory. So now you're like looking at a lot of different plans. You're like, do I want this inventory or this inventory? They both satisfy the constraints, and then now you're having to like choose between them. Does that make sense? So instead of guess check, it's like now your conceptual thinking has to be like picking between optimized inventories.
Cool. So they're still choosing the fashion. Like, what are they using their expertise for? Like, that's sort of going to be in, or what?
Yeah, good question.
What's going through their mind?
good question. So what's going through their mind right now is like, I don't understand how to do this, but I'm going to tell you how they learn how to do it. But I'll tell you the end of it.
Okay.
Like what they basically learn how to do is recognize that they used to have like an intuitive sense that purple was important.
Sure.
So now they have to put purple in as a constraint and say, give me like 30% purple, because I think that's going to be good. But unfortunately, well, both fortunately and fortunately, the algorithm can now tell them if purple was a good idea. Sorry, before they did not have to measure. Okay. Okay, so you have a sense of how the algorithm works. So I want to, this is going to be the way that I'm going to organize the findings. I think the thing that is the most interesting for you as people who care about work and AI and stuff is to understand specifically what the new and elective skills are that they have. So I'm going to organize it this way. So we're going to start with like the informal theories. This is how they used to make decisions. I'm going to tell you about the user-centered design process that the data scientists went into. It wasn't until they got to prototyping that they realized that like the buyers just fundamentally did not know how to do what they needed to do. They did not know how to think about optimization. They didn't know how to conceptualize their thinking. So it was during prototyping that the data scientists started being like, oh, we have to reskill these folks. And so they started, I'm going to tell you what they did to help reskill them. And then these are the new skills. I think this is interesting. This is my favorite part of the study because I think this is actually true of most knowledge workers. I think a lot of knowledge workers right now have informal theories about how stuff works and they don't have to measure it. But I think that is my prediction is that the high status occupations, people are going to be learning how to basically do data science on their own decision making. But I'm going to start here with the kind of the end. I'm going to start by giving you evidence. So I told you we should expect that there will not be adoption of this new system, but what I'm going to show you is actually was broad adoption. So there's this 10-year-old department, experts, high-status experts, and by the end of the study, by the end of the 10 months, you can see they had almost like 100% adoption in the women's department, which is where they started. This shows you that roughly when they were supposed to turn in their inventory plans, people were sort of on it, working up to it. The data scientists collect a lot of usage statistics, so it's nice for an ethnographer to be able to be like, there was broad adoption. Any questions? Because they measured it all, so that's cool. So broad adoption, that's surprising, that's cool. How did this work? Why did this work? That's our question. Okay. So let me give you a few quotes just to illustrate again how the buyers were making decisions in a very informal way, based on kind of their intuition. So here's an example of the buyer and the planner talking to each other. The buyer, we really think we're going to sell that for you. What color was it? Brown. I'm not betting on that, so notice selling was not betting on brown. And then the planner concedes to the buyer and is like, well, it's just numbers, because they were saying we should get some brown. And the planner's, it's just numbers. If from a product perspective you feel differently want to bet on this, then I can make this go. I don't think it's taken into account color. So the buyer's intuition that brown is not a good bet, that sort of dominates the way it worked in the past. Another example, buyer planner talking, let's just look, I was projecting, oh no, sorry, this is the planner. The planner's like, I was projecting it, I was thinking we could sell 4%. I was like, okay, that's okay. And then the buyer's like, that's not crazy. And I'm like, yeah, that's not crazy. So there's nothing wrong with it, but just you can hear it's intuitive, it's bets, it's more a sense of things. Cool. And it's still data-driven. There's projections, there's data. The other thing to notice, or another important thing of this is they're using their intuition. There's not feedback on what they do. So they will create these spreadsheets that project what they think is going to happen in their cart, basically. By the time the quarter is over and the actualized results are in, they'll stand up in a meeting and they'll just be like, well, the usual set of metrics are there, you can check them out. Now I'll just go into some of the surprising results. So they'll pick some item that performed surprisingly and tell a story about it, and that's the feedback loop. So they thought brown was gonna not be good. Was brown good? I don't know. They didn't measure it. Don't know. There was not any theory decision result kind of feedback loop is what I'm trying to say. This is their manager. at like one of these meetings at the end of the quarter where they're talking about the results, and she's like, I think there's this opportunity to like go like buy cheaper stuff, like a different success point or whatever, and that really would have helped out. So she looks into everyone and is like, I think everyone could maybe like action on that decision. But that's the only feedback that she gave them. She wasn't like, you said no brown was hot, what happened? She was just like, nobody talked about the decisions that were made and the outcome, the results that happened. They just would look at what happened and be like, there was an opportunity here that we missed. Okay, so that is evidence that these are informal theories. That is what I'm trying to show you, informal theories. Okay, next. So what happens is you have some data scientists come along. There's a lot of ways that data scientists can work. In this case, I got to follow a data science team who very deliberately engaged in a user-centered design process. Everything that they were doing was intended to be very empathetic and to really understand the problem and to see if they could help with it. So this sort of orientation towards empathy and helping, you can see in all of the way that they're designing their process. So it doesn't have to go this way. So here's evidence of them researching user needs. So they interviewed a lot of people. They observed people. They watched them using the spreadsheets. They watched them using an old algorithm tool. And they got a lot of complaints. And they had this like whole report out where they got a lot of buyers together. And they're like, here is everything that we learned from you, including like a lot of complaints about an old algorithm tool. So it's very candid. It's very comprehensive. It's very exhausting. So they spent a lot of time deeply understanding user needs. So you can imagine how engaging that is for users. Next, they held a design workshop. So they had both buyers and data scientists in this like offsite, great food, lots of discussion about like, what's the vision? How could we do this better? And after lots of discussion, this is like their actual slide about the reframing. They asked a question like this, like, what are the buyers actually trying to accomplish with rebuys? Like this whole iterative, like guess and check, what are they actually trying to do? And they realize they're trying to transform, this means like their targets, like their budget basically, into their inventory plan in a way that optimizes business metrics. That's so smart. That is so smart. That like unlocks a huge new capability, but it's also very empathetic. Like it actually is doing what they need to do with like really good math. Like, so good. And then they say, what if we try to solve that problem instead? So they're not doing two, they're like building four, which is very empathetic. So you can also imagine that the buyers love that. Okay, last thing, here's like so research design is very empathetic, problem definition. And then when they were doing ideating, this is a schematic of like sort of how the inputs and outputs. So this is like, these are variables the user puts in, this is like the data, whatever. This is the optimization algo. But what I want to point your attention to is this is all this stuff. These are all the verbs that the buyers can do now. So they ideated, they were like, if we create an optimization algorithm, what can our users do? Look at all this stuff, assess, explore, query, iterate. So there's all these like brainstorms where it's like capabilities, new capabilities for our users. So again, like how exciting for you as a user if somebody is like building a system that's going to give you all these new verbs that are kind of things you wanted to be able to do. Okay, that was way too easy and way too cheerful, and algorithmic design never is that easy. Something has to go wrong. Here it comes. So basically what happened was they built a prototype based on all of this user research, all of this great reframing, and during the prototyping sessions, what they discovered is just that the previous workflow, the previous skills that the buyers had when they were like putting stuff in the cart and just like looking at it and like thinking like about one inventory at a time did not prepare them to be able to think about, to like have the skills that they needed to have to do optimization. So starting with the prototyping, the data scientists had to like really slow down and change the way that they were interacting with the buyers. At this point though, they have engagement, trust, empathy, understanding. They have structured weekly meetings. They have like an incredible amount of buy-in at the time when they need to start reskilling the data scientists. So this was very unexpected, but I think all of this kind of pre-work allowed this to go differently, basically. So what I'm going to show you is the new skills that the buyers needed to have and the way the data scientists helped them develop them. So the buyers are going to need to be able to articulate their theory. So Liz's example, I think purple is going to be good. They just didn't think like that. They didn't know how to say that up front. I think purple is going to be good and I'm going to test it. So they had to learn how to articulate their theory, and then they had to learn how to conduct tests of their theory to see if purple actually was good. And then they're working in a very uncertain world. This is not A/B testing. This is not machine learning. This is still very open-ended strategic. So they had to learn how to articulate assumptions and trade-offs. So those are things they did not know how to do. This was nowhere in their skill set to start out. So the data scientists helped that by, they would ask very open-ended questions. They actually added system features specifically to help develop these skills. And then they conducted trainings. They used a lot of metaphors to help people develop intuition around how to do all this stuff. So I will not kind of nose that data. So I'm going to do it like this. I'm going to give examples of each of these three things across each of the three skills so you sort of get a sense of what this looks like. So actually I'm going to go forward one just to show you what the interface looked like. So the buyers would basically put in their constraints here, and then the algorithm would recommend buy these things, and it would calculate all of the metrics for it. So a buyer put in her budget and said, well, actually, let's play this game. Let's say that she has 10,000 units and she doesn't put any constraints in. She just 10,000 units and she's optimize profit. I have 10,000 units of jeans, optimize profit. What is the algorithm going to tell her to do with 10,000 units?
10,000 jeans of one color.
10,000 of one kind, of the most profitable pair. Exactly. Yes, exactly right. So that's what happens. So that she puts no, because she doesn't know how to theory. She doesn't know how to do purple, make half of them purple. So she just runs it. It says buy 10,000 of this profitable pair, and she's like, that's a ridiculous inventory. But she's like, why would I do that? So she says that. She's like, it says 10,000 of this unit. And the data scientist is like, oh, that's interesting. An open-ended question. Oh, that's interesting. What did it put it into? She's like, oh, it says 10,000 units into this profitable thing or whatever. So here, this is starting to do the reskilling, right? So she says, yeah, so that's the expected behavior. If you don't tell the tool to force some amount of breadth of style, the tool is just going to put everything into the best one. So that's where you get to be creative to pick out what kinds of breadth, right? So open-ended tells her, here's a new skill. You have to impose it for your own creativity. So tons and tons of questions like this, very interactive. They also added system features. This is back to the Zuboff. Zuboff talks a lot about the action context. Actually, some of the talks earlier today were like this too. The action context is where you learn. So when the buyers were interacting with just an interface like this, they were like, I literally don't understand what's happening right now. But when they started to give them a visualization tool, and these are pivots basically, you can visualize the inventory. So now you're looking at it and you're like, there is a lot of gray in that inventory. Do I mean that? Oh, I see that's coming from this constraint. So being able to go back and forth between constraint and a visualization was key. So the data scientists built them a visualization to help them be able to better understand and think about how to create a theory here. Here's a buyer talking about what that's like. So seeing the visual here and having the flexibility of slice and dice the assortment is so awesome. Now I can see if it's a good rebuy. Is it all one color? How's it looking by brand? Each of those variables are her theory. Brand, color, silhouette. So she's learning variables that she's going to put into the system. Lastly, they would help elicit their informal theories by conducting trainings and using a lot of metaphors to help them build intuition. I think this one is so interesting. They're teaching them about optimization. So let's look at our axes. Amount of pie eaten, happiness. How much pie should we eat at Thanksgiving if we're trying to optimize our happiness, right? And it's saying there's different constraints. So if it's if you want the most happiness, you're down here, but if you've put a constraint in that means this amount of pie is not possible, then you're, right, it's local maximum, global maximum. And they teach them that by using an apple pie metaphor. Okay, so that's how to elicit their theories. You're like teaching them how to think about it. And then they teach them how to propose, conduct, and evaluate rigorous tests of their theories. So here's an example of an open-ended question during prototyping. Here the buyer is just saying, like, I think we don't bet high enough, is basically what that says. I think we don't put enough bets in it. And the data scientist replies with a great open-ended question. Interesting. What information would make you feel comfortable making that bet? And the buyer thinks about it as like, oh, yeah, I guess if it like gave me a big boost of profitability, how much uncertainty and stuff like that. So you can see they're starting to help her think about how you would actually test that theory, what information you would need. Another example, the data scientist put a variable in and said we don't have to include that, but including us allows to see if this assumption is true, like teaching them how to like test their assumptions, in other words. And the buyer, oh, I guess that's important to know because we don't usually use that variable. And here's adding system features to help them propose, conduct, and evaluate rigorous tests. Basically, they would just like let them put in any variable they wanted to because it just tested it. Just put like, they're like, well, I think that corduroy is going to be a big deal. So they're like, that's an attribute we can measure. So they put corduroy in and then just teach them how to measure it. So adding as many variables as they wanted to, which is an interesting choice for like driving adoption, right? And then again, conducting trainings using metaphors to help them know how to like propose, conduct, and evaluate their tests. So here's another example of like metaphors. I'm not going to get into this in too much detail, but they used a metaphor of buckets to help them understand how to use a particular variable of sell-through. Okay, so last thing is you're helping the experts learn how to talk about trade-offs and assumptions. So here the data scientist is saying, let's say you could do your inventory plans in two ways, one where you do it this way, and one where you follow the recommendation of the algorithm. Is there a metric that you'd want to say, like it would have to like net X extra dollars to make it worth the cost? So like what would have to be true for you to make this bet, in other words? And the buyer thinks about it, and then starts to think about like what would have to be true for her to be willing to make that bet. I'm going to come back to this one. In the trainings what I'm trying to say is these questions are happening also within the context of these trainings. So they'll show them an example of like where you're trading off something like profitability with another metric. And they'll actually like graph it for them and help them think about, within an optimization, you can get a lot of something, but you're going to be trading off something else. You can see in these key intuitions, if you remove targets, then you just get more of one thing. You're going to get a higher like variable that you're optimizing. If you impose targets, you're going to get broad inventory, a lot more styles. Last thing, adding system features again. So I'm back here to assess, explore, curate, iterate. Here what I want to say is this idea of save and share. This is a system feature. This is back to when I'm showing you there's like 20 carts and you're picking among them. So if you can save your plan and compare it to another plan, which is a brand new capability for them, then that teaches them to look and be like, oh, this one I did force a lot of like color breadth and I sacrificed profitability or something like that. So when you can save and share and compare your assortments, that system feature allows you to theorize differently and understand the trade-offs that you're making differently. Okay, so those are the new skills. That's how the data scientists helps them develop it. I'm going to end with this cool story that is evidence that the buyers did develop this new skill. So this is at office hours. The data scientist is holding office hours, and the buyers come to the data scientists with the following piece of information. So they say, hey data scientists, we put together a list of all our styles we buy. We looked at the algorithm's predicted metric, and then where it's actualizing. So they got results, and they brought it back, and they said, ultimately, we're seeing softness across the board. Doesn't matter like what silhouette it's in. Let's say on average, it's a 7-point difference in what we're actualizing versus the predicted. So in other words, the data scientist made an algorithm that was predicting, let's say, 90, and the business results are 83. And who told him? What? It's our fashion buyers. Like they learned how to measure. They learned how to measure the actualized business results to the fact that they became empowered and they came and challenged the data scientists who were like, your algo is predicting way too high. And he actually liked it because, I mean, that is really good user feedback, right? So, anyways, so that's fun. That is a cool example of how humans can become informated and augmented using algorithms. I've already said this, so I'm going to leave this slide up in case we want to talk about it, but I think the contribution that I think is interesting is the specific skills that were needed, and then the specific process, basically, whereby those skills were able to be developed by these experts. Marlon, yeah.
Hey, thank you so much. Something that's interesting about your setting, with the fashion buyers that I don't know if you highlight enough is that the usefulness of like historical data, it operates differently in the industry. So, full disclosure, I watch Devil Wears Prada like every year because I made my. But seriously though, like a lot of the cultural industries are centered on predicting what's next or basically encouraging trends, right? Or setting trends. And so did you get a sense for how these fashion buyers may have been trying to coach or help the data scientists understand that these models may have limited applicability? Like to Liz's point, a lot of these people get to decide that purple is going to be the thing for 2024, and that's a very different application for optimizing when that buyer has like way more influence and power than the typical users or the typical user of a data generated system. Could you share?
Yeah, totally. That's such a good question, and I feel like the Devil Wears Prada is like the perfect illustration. You're thinking of the moment where like Meryl Streep is like, I picked the blue.
Yeah, exactly. Of course. Yeah, and she puts that poor representation of Northwestern in her place. Yeah.
Yes. Great question. And so the way that it worked here, because you're exactly right, and I think part of the story of adoption, which I'm glad you asked this question because I should have said this, is they did the inventory planning around what's called rebuys. So old styles that they were going to like refresh and sell again, which meant when a buyer was doing their inventory plan, they still had like 10% that was like for newness and freshness. And they started to learn that like they could have a lot less risk in rebuys to sort of cover the newness, to cover like places where they could be more like avant-garde and like whatever they were doing. Does that make sense?
Yeah.
So I think a lot of the adoption was because
it's like hedging their risk.
Yeah.
All right, cool.
Yeah.
Thank you.
Yeah, good question. Yeah.
So one thing that seemed implicit in here that might be helpful to make more explicit is it seems like the process of being able to step away from their work and do the abstraction that you demonstrate happens because they need to interact with these data scientists, right? And they're sort of pushing back against the data scientists sometimes. The data scientists are coming to them and saying, try this out. And there's something in that interaction that that allows them to think about, describe, reflect on their work in a new way. Their ability to do that came through pretty strongly, but I think it might be helpful to just show that process arising more from interaction. But it also makes me think, what would happen if they didn't have the data scientists here? So what if the company sort of cheaped out and was like, hey, we just bought this third-party algorithm and we're dropping it in. Would they be able to do the same kind of intellective work, do you think, without the ability to sort of engage and negotiate and get the feedback?
I mean, that is such a good question. Yeah, and you and I would both be speculating, and I think we both would say no.
It would seem like, or at least it would be different, right?
Yeah, it would be different.
They might develop more folk theories about why things are working the way that they are and what they're trying to act on them.
Scientists, the company allowed them to go, as opposed to companies that don't allow them to go. It has to do with the organization in which they live. Here, they're allowed to go. Instead of saying, you have to do this we codified how you're doing your work. We took the best buyer, all of you do the same.
Yeah, totally.
It's a very different attitude.
Yeah, totally. Yeah, Liz.
I'm curious if you connected this work to the data literacy work and data visualization work. There's some interesting work going on this campus who are saying, okay, great, we have all this data now, but people really don't understand what it means. And so I wanted to know the story of how they come up with the buckets, why they decide that, to use that, or why they did the apple pie, right? Why that? And I think there's a growing body of literature that's saying, like, okay, you want to teach somebody this principle. Here's the most effective way. Here's a way of presenting the data.
Yeah.
It could be really a fun overlay.
Totally, I love that. Thank you for the
Yeah, I'll give you some names.
Yeah, I have not engaged it, but I love that. Yeah. Yes.
Yeah, and just building on both of those, to me, one thing that came across in here, this is very interesting, but one thing that came across is the work of the data scientist is that part of the, I don't think that's the typical way the students were training, or they have this idea of empathy and open-ended questions and understanding, and yet just informal, some of the informal interviews I've done in the healthcare area where they are, that's where they've had some successes when they've been able to partner with the user like this.
Yeah, it's totally. Yeah,
I
that's
think
it.
that work is also, the nature of that work is
Yeah, I think that's true. Yeah, and actually, I mean, and again, I'm kind of joking, but not really. Like reviewers who like this is way too good of a story. They were like, because the data scientists are so empathetic. They really
Yeah.
they sit there and they think about it and they try to think of a question that's going to help the user understand it.
which is not in our curriculum.
That's not being taught. Yeah, for sure. Yeah, yeah.
So maybe a question there is, are the data scientists becoming informated? Or maybe they already had become years before because they've been at this company and worked with other folks. And so I'm kind of curious if you flipped the script a little bit and thought about the data scientists and if you kind of done that already there.
It totally is. Yes. I have a version of the paper before where I was basically, like I was looking at everything the data scientists did not understand that they had to understand from the buyers. So that like back and forth to like develop the algorithm, it's definitely there. My reviewers felt like that was already sort of known, but I can say, like, I have a version of the paper that basically is like, here's everything the data scientists did not know that they changed or had to learn over time. Not a real quibble, but like I wouldn't say informated, just because informated tends to be like data, you know what I mean, like more like quantified sort of. So, but they became much more aware of the context.
Yeah, because they could be on both sides. It could be the empathy they developed, which is of course hard to quantify, but it could be also that they could bundle fashion products better.
Yeah.
Perhaps the conversations happened and they could do that.
That's good. I like that. Yeah, totally. I was a first student, I think.
Yeah, so this is a good example in counterpoint to what we heard this morning, where the human wasn't in the loop in the system design. And here, however it happened, deliberately or accidentally, they were.
Yeah.
That's a big part of your story.
Yeah.
And the other part of the story, I think, I mean, you alluded to this in the beginning, is these were basically high-skilled folks to begin with.
Yeah.
So they had some potential to gain.
Mm-hmm.
Many decades ago, Georgia and I had an opportunity to collect data from GM was putting a robotic assembly line, a prototype in place. And we were able to build a little questionnaire and query folks. And if you were one of the line workers, it was a threat.
Mm-hmm.
But if you were skilled trades, you were going to likely get trained to have
more skills and have more opportunities.
Yeah.
So it's really kind of a question of how did this affect you? You're out. This is a better opportunity. So this is the better opportunity half
Yeah,
of this.
exactly. Yeah. And
Right,
it's,
so
I don't think I like fully understood until I like been into study and like reading this book that that's something that is actually like really expected. Is your high status people are the ones who are going to become augmented or informated, and the people who are not like already like low status are the ones that are going to get paid up.
or could be, right?
Could be
Because
paid
then
up.
the other side of this is, to some, well, I don't know, in this particular example, maybe they didn't need a lot of input from the designers to design the optimization routine, but a lot of times you need the experts, you need to elicit the knowledge from the experts to design whatever algorithm you're going to do.
Yeah.
And then if I'm not committed to that, why would I help you do it well?
Right.
I mean, there's some cool stuff by Roy talking about, back when scientific management was the thing.
Yeah.
So
Is it like
that they had elaborate, the workers had elaborate routine ways to add extra time and steps into their routine to stretch out the timeline. And then other informal collusion would develop to help them maximize the quota when they were on the clock.
Yeah. Totally. Yeah. You actually I'm glad you made that comment because you reminded me. I forgot to say. I'm like, oh, look at the buyers. Like they got informated. Do you remember their planners with the calculator? So, yeah.
what happened.
They're doing other things. They're helping label data. They're currently fine.
Last question, just.
This
I'll
may,
make it a good one.
yeah, this may go. Pressure's on.
I know.
This may go beyond your findings here, but what are the what are the stakes here? Like, what are the consequences of them developing these kinds of intellectual skills or not? You know, like, are they in danger, or were they fearing they were in danger of losing their jobs because an algorithm could do better forecasting behavior? Are they, you know, shaping their interactions with other people in the organization differently, right? As the role changes, shift in the role relation changes, and that to use that vocabulary. Like, I'm just curious, what, like, it's great that they are now changing the kinds of skills they use and they deploy on a daily basis, but why?
Yeah, great question. So I think are not afraid of losing their jobs because it's an optimization algorithm. You do have inputs and you do have a lot of interpretation of like trade-offs and assumptions. So the nature of the technical system is keeping a lot of human involvement, right? Like the data scientist did not have to make it an optimization algorithm, but that allows for a lot of like input and interpretation still. So I think the buyers end up with new skills that do port. Like it is actually useful to be able to conceptualize and optimize inventory and to like articulate trade-offs. Any company you're at, that's a valuable skill. So the buyers really lucked out because they were the users of this system that did informate and augment them. I didn't talk about the planners, and that's just because most of my data was just by luck. I could have picked the planners and then I would be telling you a different story, but just by luck I picked the planners, or the buyers. So the planners, the planners did, like they were doing all the manual computation that now is done in seconds. So like their work was automated. So that role structure did profoundly shift. So what are the stakes? I think high status occupation got valuable skills that will generalize. Like they could get higher paid jobs with the ability to do some of this stuff. Because that's what Zuboff predicts is like the managerial stuff is like the more high value stuff. And then the adjacent occupation was automated. So that's big stakes. Yeah. Not yet. Like everyone's still deployed at the time. I would have.
Just one quick, made me think that this may inadvertently make the ones who see the trends more valuable. I mean, these skills.
Oh, if they could prove it now. Yeah, totally.
Yeah, I mean,
That's true.
yeah, because these skills can be often seeing the trends.
Yes. That's true.
That may become.
Especially if you could, because you could prove it. You could be like, I said purple.
All right, one more round of applause.
Ah,